Good day, everybody. Welcome to this class. This is physics revision class. It is purely physics revision class. So this will be our first revision class, and it's also called Rhema class for Jamb students, WAEC students that have read a lot, but they need the main point, or they need some tips on how to remember all they have learned so far. So this class will be simplifying a lot of things. So we don't have time. Let us just quickly start what we want to do. So I will start with mechanics. And mechanics, because my revision won't just be jumping from here to here, trying to cover everything. I also make the revision simplified and detailed, so we might not finish everything about mechanics in this video. So under mechanics, I will start with motion. Inside motion, I will talk about the equations of motions. I will talk about Newton's law of motions. I will talk about Newton's formula for motions. Then after motion, the next one we talk about is work, energy and power. Work, energy and power. After work, energy and power, the next one we'll talk about, after work, energy and power, the next topic we now go into will be elasticity. And after elasticity, I think let us just do it 3 by 3. Yeah, 3 by 3, so that it will be, we know we'll know how we can go about it. So we'll do it 3 by 3. So after elasticity, then I might add simple harmonic motion. So simple harmonic motion. So let's start from the first one, which is called motion. The first topic, which is motion. So what is motion? Write it down. Motion can be defined as the change in position of a body from one point to another due to an applied force. Motion can be defined as the change in position of a body from one point, let's say the body is at point A, to another point B. So the process of this body changing its position from this point to another point is called what? Motion, right? So we have types of motion. The first type of motion I will talk about is called linear motion. The first type of motion is called linear motion. What is linear motion? Linear motion is the change in position of a body along a linear path. For example, we are considering a linear path. Another name for linear also can be explained with straight line. We also have the body moving in a straight path, or a linear path is called linear motion, right? So for example, if a car moves from point A to point B, in this movement it undergoes what is called linear motion. After linear motion, the next type of motion we will talk about is called, now also note before I go to the next type, another name for linear motion is also called translational motion. Translational motion. Make sure you are writing this down. Translational motion. So linear or translational motion is the motion of a body along a straight path. Make sure you are writing this down, because you must apply hard work for you to get a lot of good grades. Alright, now the next type of motion I will talk about is called circular motion. Circular motion. What is circular motion? Circular motion, are we getting it now? Is the motion of a body along a circular path. Circular motion is the motion of a body along a circular path. Are you getting it now? Let's say we have a stone. The stone is moving around a cycle, and somebody is wheeling the stone across his head. Are you getting it now? If you observe, this stone is moving along a defined cycle, along a defined path. That defined path in form of a cycle makes the stone undergoes a circular motion. Are we getting it now? Let's say a car is at a point, at a junction, a roundabout, and this car wants to move to the other road coming from this road. Are we getting it now? The car wants to move to another road coming from this road. The car will have to turn around, right? The car will have to turn around. This path in which the car have turned for it to move to the other path in a roundabout is called a circular motion. So the car undergoes a circular motion along this path, right? So a circular motion is the motion of a body along a cyclic path. This is very, very important. Circular motion. Now, the next type of motion we talk about is called rotational motion. Rotational motion. Rotational motion. So there is difference between circular motion and rotational motion. There is difference between circular motion and rotational motion. So what's rotational motion? Before we begin to go into rotational motion, let's take an example. Let's say we have a disc, right? Okay, this is a disc, LCD plate, for example. Now, this disc now is fixed. Let's say it's fixed at a point here, right? Now, this disc now begins to rotate. Let's say it begins to rotate. It begins to rotate. Let's say this disc begins to rotate, right? So from here. So from here also. So I begin to rotate these discs. When I begin to rotate these discs, what will happen? The whole body will begin to move around a fixed path, right? The whole body will begin to roll, right? So now the difference between rotational and circular is that in circular the body is moving along a cycle. So this is the body. Is moving around a path. Why circular motion? Why rotational motion? The whole body is rotating along the fixed path. Is the whole body. The whole body here is rotating. The whole disc is rotating along one fixed point. So that is what we call rotational motion. So the rotational motion can be undergone by a wheel, a tire of a vehicle. It undergoes a rotational motion. Are we getting it now? Yes, because the whole tire is rotating. Now there are questions that come out in Jamb. When you see, they say the tire of a vehicle undergoes A, circular motion, B, translational motion, C, rotational motion, D, circular and rotational. Let's say E, rotational and translational. What will be the answer? The answer is E, rotational and translational. Because as the tire is rotating, right? As the tire is rotating, the tire is also moving. So it's rotating and moving at the same time. So it's rotating, which is rotational, and moving, which is what? Translational. Are we getting it now? Are we getting it? All right. Now the next type of motion we go into is called, the next type of motion that we like to explain is called random motion. What is random motion? What is random motion? Random motion is the zigzag unspecified movement of a particle. It is zigzag unspecified movement of a particle. Or we can say random motion. Make sure you are writing this down. Random motion is the movement of a particle or of a body along an unspecified path, or along a path which is not specified. So random motion is the movement of a particle along an unspecified path, or you can define it like this: random motion is the unspecified movement of a body along a path, right? So it's moving along a path, but it's not specified. For example, we can say if a 4 is a feather or fowl, or a nylon, or a wool. So let's say let's move let's take a 4 for example. A 4 will move zigzagly down. We cannot specify. You cannot specify the next direction where it's going. Zigzag movement. So you can say the zigzag movement of a body along an unspecific position is called what? Random motion. Are you getting it now? But there was a question I saw in one textbook and said a woman looking for her son in the market undergoes what type of motion? Translational, rotational, random, oscillatory. So what type of motion is that? The answer is zigzag, because a market is a crowded place, right? So since the woman is looking for her son, that means that the woman does not know the exact point where her son is. So she is not specified about her path. So she will be moving to and fro. Are you getting it now? Yeah, and you're looking for her son in different zigzag directions. So that answer is what? A random motion. Alright, so the next type of motion we'll talk about. The next type of motion, make sure you are writing those things down, because these are what we call exam bullets. They are we release them in last minute so that you find them useful as what we call last minute miracle. Now the next type of motion is called oscillatory motion. Oscillatory motion. Oscillatory motion. What is oscillatory motion? An oscillatory motion is the motion of a particle that repeats the same type of motion at a specific time interval, right? For example, let's say we have a single pendulum like this, right? This is the position at rest. So if I count 1, 2, it moves like this to this side. If I count 1, 2 again, it goes like this to this side. If I count 1, 2, it goes like this to this side. So we discover that every 2 seconds, the particle is swinging and repeating the same type of movement. 1, 2, 1, 2, 1, 2, 1, 2. This is what we call, this is an example of what we call what? An oscillatory motion. We studied oscillatory motion in detail at a topic called simple harmonic motion. I think those videos I've already done there before, so if you want to watch them to detail, you go to my last video. Another example is a spring. Alright, so after this, the next type of motion we'll talk about, that we'll talk about here is called, after oscillatory motion, the next type of motion we would like to talk about. Okay, I think which one is remaining? We've done translational, we've done random, we've done translational, we've done circular, we've done rotational, we've done random, and we've done oscillatory motion. I think this is all we need for now. Yeah, this is all we need for now. Alright, so we are through with motion. Types of motion. So the next part we'll talk about in this physics revision Rhema class is, we are still under mechanism, is time, distance, and speed. So next we'll talk about distance, we'll talk about time, talk about distance and speed. So the first one we'll talk about is time. What is time? Time is defined as the measure of events. Time is defined as the measure of events, right? So events to come, as the measure of event to come. It might not be measure of event to come, it might be event in the past. It's just about measure of events, right? So if we have something about to happen, we might call it event, and the measure of when it will happen, or so when it will happen, the interval is called what? Time, right? So that's just time, and the unit for time in physics is in seconds. the unit is in seconds. It's very important. So if they give you hour, most times make sure you change to seconds, but depending on the questions you might know to change. But most times physics question, when they give you question in hour, you change to seconds, right? So the next one talk about, so okay, in O level, time is a scalar quantity. Time is a scalar quantity. The next one we'll talk about is called distance. What is distance? Distance is defined as the difference between 2 points. Distance is defined as the difference between what? 2 points. So now, is distance a vector quantity or a scalar quantity? Distance is a scalar quantity, right? And the unit for distance is in meter. Unit for distance is in meter m. If they give you this in kilometer, make sure you change it to what? Meter. Alright. So let's talk about speed. What is speed? Speed is defined as the rate of change of distance. Remember, we are doing O level, we are doing revision, so I won't need to go much detail. I'll just give you the main point. So speed is defined, you can write this down, as the rate of change of distance. So we can say that speed, capital letter X, is equal to distance over time. Now, the unit for speed is meter per second, right? This is the unit for speed. And why is it meter per second? Because the unit for distance is in meter, and the unit for time is in seconds, right? So meter over s is become meter per seconds, right? Although there are other units for speed which is in kilometer per hour, right? And others. Now listen very carefully. Speed is a scalar quantity. Speed is a scalar. So we discovered that all we have been doing from time, distance, and speed, they are all scalar quantities. So I made it so. The reason is because I want us to go into the scalar form of motion before we go into the vector form of motion. Alright, now let's say, for example, we have a man covering a distance of, let's say, 30 meters, right? So let's say question 1. A boy runs or covers a distance, make sure you write this down, of 20 meters in 2 minutes. Yes, a boy covers a distance of 20 meters in, or let's just make it, sorry. Let's say a boy covers a distance of 60 meters, right? Of 60 meters in 1 minute. Calculate the speed. So speed is equal to distance over time, right? So when you hear 60 meters, it means that the distance is what? 60. And the time is, now they said 1 minute, so that 1 minute you will convert it to seconds, and to convert from minute to seconds you multiply by what? By 60. So that would be 1 times 60, that's the same thing as what? 60 seconds. So that means time is equals to what? Time is 60 seconds. Alright, so from here, since time is 60 seconds, when we now substitute into the speed distance formula, speed distance time formula, this is what we now have. We now have s to be equal to, so distance is what? 60, right? And our time is what? 60. So 60 cancels 60, we have 1 meter per second. That's all. So now, what if you want to convert from speed from meter per second to kilometer per hour, and from kilometer per hour to meter per second? So to convert from kilometer per hour to meter per second, to convert from kilometer per hour to meter per second. From kilometer per hour, right? From kilometer per hour to meter per second. What we just do is to multiply. We multiply by, so we multiply the kilometer per hour value by 1000 over 360, right? So for example, now convert, let's say we have a question in which the speed they gave you was 50 kilometer per hour. You know you are not supposed to solve with this. You are supposed to solve with meter per second. So to convert this 50 kilometer per hour to meters per second, you have to first of all multiply it by 1000 over 360, right? Then your answer will now be what you will use to calculate. Alright, so I think we are done with that. The next one we'll talk about displacement, velocity, and acceleration. Displacement, velocity, and acceleration. So let's talk about displacement. What is displacement? Listen very carefully. Displacement is defined as the distance, make sure you are writing this down, moved in a specified direction. Now note, displacement is different from distance. What is the difference between displacement and distance? Distance is not specified. It's just the difference between 2 points. Now displacement is the distance towards a specific point, right? For example, now let's say we have 2 walls. The distance between that 2 walls, are you getting it now? The value of the length between that 2 walls is distance. But let's say I started from the first wall and I'm walking towards the second wall. Are you getting it now? That is called displacement, because my distance is now specified. Now listen very carefully. Displacement is the distance moving in a specified direction. Since you have written that down, displacement is a vector quantity. Displacement is a vector quantity. Why? Because what are vector quantity? Vector quantity are quantity that has magnitude and direction, right? Now the magnitude is the value of the distance and the direction is the specific point in which you are moving the distance to. All right, now the unit for displacement is also in meter, right? Because it's the distance moved in a specified direction. All right, now the next one we'll talk about is velocity. Make sure you remember this thing very carefully. The same way speed is the same as distance over time. Now the symbol for displacement is x, small letter s in O-level physics. So velocity is defined as the rate of change of displacement, right? So velocity is defined as the rate of change of displacement. Velocity or speed talks about how fast a body is. Now the difference between velocity and speed is that speed talks about how fast a body is, but it's not specifying it to a specific point, right? While velocity talks about how fast a body is towards a specific point. Now, so we can now say that velocity is what? The rate of change of displacement. Are you getting it now? So we can now say that velocity is displacement, small letter s, over time. Are you getting it? Now, you should know that this speed, which is s, and this velocity, which is s, there's difference. The difference between this and this is that this one is capital letter S for speed, right? For displacement, this is small letter x. Now, displacement is velocity is a vector quantity. Write it down. It's a vector, and the unit for velocity is in meter per seconds. All right, so I think we are through with this. So we can now go to the next. All right, so the next one we'll talk about is acceleration. So before we go to acceleration, let's just do, we are doing revision class, but let's just do a quick question. Calculate the distance of a boy. I won't write it down because of time. Calculate the distance of a boy. Calculate the displacement of a boy. Calculate the displacement of a boy moving with a velocity of 4 meters per second in I guess in moving velocity of 4 meters per second in 10 seconds. So it means that your time is what? 10 seconds. Now they say calculate the displacement. So that means small letter s displacement is what? Unknown. So I told you how to solve problem in physics. First of all, you write out the parameters, and these are the parameters we have written out. This and this, right? So the next thing is to look for a formula that connects everything together, and the formula is what? V is equal to small letter s over t, right? So that means that in position of this v is 4 equal to s. S is unknown, that's what we are looking for. Then small letter t is what? 10, right? So make s subject the formula, we cross multiply. So, right? Why are we crossing multiplying? Because we want s to stand alone, and once s stand alone, that means that is the value for x. So when we cross multiply, we have 10 going to meet 4, so that becomes 4 times 10 is equal to s standing alone. So s is equal to what? 4 times 10. So x will now be equal to what? 40. 4 times x is 40 meters. So the displacement of the boy is 40 meters. I think this is explanatory enough. Alright, so the next one we'll talk about is acceleration. What is acceleration? Acceleration, now let's imagine that a boy was moving. Okay, although it's a bad example, but for the purpose of making it clear, we reject something like that in Jesus' name. Alright, so let's imagine that a boy was moving gently home, right? He was moving home gently. Was moving like this. Moving like this, small, at a constant velocity, which means that his speed did not increase or decrease. Immediately, when he looked back, he saw a snake. If that boy sees a snake at his back, he will increase his speed, right? So the person that was walking like this, when he now sees the snake, he begin to like walk fast. He begin to walk very, very fast, right? Now that process of moving fast, he increased his speed. True or false? We can also say that since he's moving towards a specified point, he increased his velocity. True or false? Now that increased in velocity at that time is called acceleration. Now let's take another example. Let's say we have a car moving, and there is a speed breaker on the road. When the car gets to the point of speed breaker, it will slow down, and when the car leaves the point of speed breaker, it will start increasing the speed, right? Now that process of the car increasing its speed is called acceleration. Acceleration is the change in velocity of a body with time. Are you getting it now? Acceleration is defined as the change, make sure you are writing this down, as the change in velocity of a body with respect to time. Acceleration is the change in velocity with respect to time. So we can now say A is equal to change in velocity, are you getting it, over time. We can also designate change by delta. So we can now say that A is equal to delta V over T, right? Now, when we have two velocity values given to us, is the same thing as saying delta V is the difference in the final and initial velocity. We can now say that delta V is equal to V minus U all over T. Are we getting it now? Are we getting it? So acceleration is the change in velocity with respect to time. So the formula you should note here is let me just drop the formula. It's on your screen, but let me just rewrite it so that you get it clear. So the first formula to note here is A is equal to change in velocity over time. The second one to note is A is equal to delta V, still the same thing as change in velocity over T, right? Which is also the same thing as, note this, V minus U all over T. This is the formula for acceleration. So let's take a simple example before we go. So a simple example. Let's say that a car moves from rest, right? A car moves from rest and travel. So the car moves from rest and travels with a high increased velocity of 3 meters per second. No, obviously the car can't move. Okay, let's say this is 30 meters per second, right? So the car increased the velocity to 30 meters per second. Are we getting it now? Let's take the time to be let's say the time is 1 minute. Calculate the acceleration. A is equal to unknown. So how do we find the acceleration here? Now listen, when you hear rest in physics, especially mechanics, it means that the initial velocity of that body was 0. So when this rest is the same thing as saying initial, the symbol for initial velocity is U, right? We are trying to apply that previous formula. Then the symbol for final velocity, which is 30, is V, which is equal to 30 meters per second. Now 1 minute, when we talk about 1 minute, we convert this 1 minute to seconds. That is 1 times 60, right? Which is what, 60 seconds. All right, so in this case now we apply the formula. A is equal to V minus U all over T. So that is the same thing as our V is 30, our U is 0, all over our T is 60, right? So this is the same thing as saying 0.50 meter per second square. So that's the answer. Oh, sorry, I didn't drop the unit for acceleration. The unit is meter per second square. That's the unit for acceleration. And acceleration is a vector quantity. Acceleration is a what? Vector quantity. So I think we've done some things now, right? So the next one we talk about, because we are doing revision, the next one we talk about is called the equations of motion. The equations of motion. The equations of motion, the equations of motion. In talking about the equation of motion, there are 4 equations of motion. For these 4 equations of motion, we concentrate on 3 because any question can be solved using the 3 equations of motion, right? So let's go into it. The first one is V. I think I did thorough lecture on this topic. go to my first video to learn the derivation and everything. I'm doing revision right now. So V is equal to U plus AT. Second one is X is equal to UT plus half AT squared. Right? The third one is V squared is equal to U squared plus, this is U, plus 2AS. And the last one is X is equal to what? U plus V all over 2 times T. Right? Now listen very carefully for in terms of the parameters. V is called velocity, not just velocity, it's called final velocity. Right? It's called final velocity. U is initial velocity. Initial velocity. S is called displacement. S is the displacement of the body. You know displacement, distance moving in the specified direction. YA is acceleration, and T is time. And T is equal to what? Time. If you know those things and you know change of subject or formula, that means life will be easy. Right? So we don't have time. I will just solve one problem here. Just solve one problem. I will form the question right now. Then talk few things about motion under gravity. Then we move. So first of all, note very carefully. Note some things. The first thing you should note is that acceleration here, right? Acceleration. Make sure you write this down. So I'm cleaning it. Acceleration is of two types. We have positive acceleration, and positive acceleration is called acceleration. And we have negative acceleration. Negative acceleration is called deceleration, or is called retardation. Are you getting it now? What is deceleration or retardation? Deceleration or retardation is the slowing down of velocity. Are you getting it now? Now I told you that the increase, when velocity is increasing, when the body is increasing the speed, it's trying to move faster, it's called acceleration. Now what if the body is trying to go slower? It's called deceleration. Are we getting it now? All right. So when you see a question, they tell you a deceleration of 4 meters per second. It means that your A will not be equal to 4. Since deceleration is negative acceleration, are you getting it now? Your A will be equal to -4. Are you getting it now? I might not solve a problem on that. I'm giving you the hints. All right. Now let's say a car moves from rest and attains a velocity of 4 meters per second. And attains a velocity of 4 meters per second. So a car moves from rest. So when you hear from rest, it means that what? Initial velocity U is equal to 0. So you can't move from rest and attains, so from rest is 0, right? I told you before, and attains a velocity of 4 meters per second. So V is equal to 4 meters per second in 2 seconds. So let's say T is equal to what? 2 seconds. Calculate the acceleration of the car. So when you see this kind of question, first of all, you now go to your equation of motion. Which equations have this parameter? As we can see very carefully, equation 1 has V, this has V. Equation 1 have U, we have U here. You have A, you have A. Okay, A is what you are looking for. They say find the acceleration. So it means A is among the parameter, and we have T. So we are suitable to use what? Equation 1. So using V to be equal to U plus AT, right? So our V is 4. That is 4 is equal to U. That is 0. U is 0 times T, which is 2, plus A is unknown A. Then T is what? 2. Right? 0 plus 2 is 0. So that's 4 will be equal to 0. So this place is nothing. There's nothing here. 2 times A is what? 2A. Right? So make A solve the formula. That means A will be equal to 4 over 2 That is what? 2 meter 4/2. Are we getting it now? 4/2. So 4/2 is the same thing as equal to being equal to 2 meter per second square. That's equal to A. Very easy. So let's take another question. Let's take another question from here. So the rest you can go to your Jamb Pass question and practice it. You can go to my previous video. I did detailed explanation on this and also practice this. Let's say calculate, write this one down now. We are on the revision class. Calculate the distance covered by a body. Calculate the distance covered by a body. So when you hear distance here, we are talking about S, acceleration. So distance is unknown because that is what they are asking you to calculate for. That move from rest. So in most questions they talk about rest. That means U is equal to 0, right? And attains an acceleration of 3 meters per second square in 2 seconds. So that means in this case now A is equal to 3 meters per second square and T is equal to what? 2 seconds. Alright, so to do this, we look at our equation VUAT. Here we have SUAT, so it doesn't correspond. Here we have SUTAT. So here it means that number 2 is likely suitable for this equation. For number 3, we have V is equal to U plus 2AS. But there's no T here, right? So we use number 2. So X will now be equal to our U here. Okay, let us rewrite it so that. So our U here, what is our U? Our U is 0, right? So 0 times T will automatically become 0 plus half 1/2 times A. Our A is what? 3 times our T is 2, so that will be 2 square, right? So that will now be equal to 0 is nothing, so that will be 1/2. Okay, so I think I need to write this on the big screen right now. So if I continue from here, that means I continue from here now. sorry. I pray one day God will bless us. We have better facilities to do this job. Just pray one day God will help us. Alright, so well, if you feel you can support us, you can contact me on WhatsApp. Alright, so X here will now be equal to, so 0 is not right, so we have 1/2 times 3, so 2 square is 4, right, times 4. So 2 going to here, 1, 2 going to 4, 2. So we are now left with 3 times 2. So 3 times 2, our S will now be equal to 6 meters, right? So thank you very much. I think I've done some revision on kinematics. The next one we'll talk about is motion under gravity. Is what? Motion under gravity. What is motion under gravity? I won't solve question on this because of time, but let's just talk the concept of this. In our previous equation, where we said that X is equal to, let's start from V. So when we say that V equals to U plus AT, x is equal to ut plus half at square v square is equal to u square plus 2as. S is equal to u plus v all over 2 bracket t. Now listen, there are two cases of motion under gravity. The first case of motion under gravity is when a body is going up. So I will call it upward. When a body is going upwards, right, its initial velocity is given, but at maximum height, at maximum height, make sure you write this down. At maximum height, final velocity v is equal to 0. Are you getting it now? Now, the acceleration, your a, will now be equal to minus g. And we know the value for g. G is 10 meters per second, which is the normal gravitational acceleration affecting anybody moving upward and downward. So see, this particle is moving upward, right? It will be affected by g, and the g is going to be negative. Why will it be negative? Because it is moving against the influence of gravity, right? There are many explanations to this. Also, you can explain it this way: as it's going up, it is decelerating because the body is decreasing its speed. The more it goes up, the more its speed is decreasing, and that type of motion is called deceleration because it's not increasing its speed, it's undergoing decrease in speed. And deceleration is called what? Negative acceleration. So that's why g will be minus. Are we getting it now? All right, so that's just it. So when it's going downwards or downwards, like when the body is just allowed to move free fall. So you let's say we had a stone at a height, we had a stone here, and we allow the stone to just move downwards, right? So what you will observe is that the initial velocity of this stone from this side is not moving, will be what? 0. So that means from here u will be equal to 0, but the final velocity will be given, right? So there will be final velocity here because it will land on the ground. Are we getting it now? So it means that initial velocity here u will be what? 0. Now what of the acceleration? A will be equal to what? G, right? Okay, so I think we are done in this section. So the next section we'll talk about here is called, the next section we'll talk about here is kinetics. So I will just do some things on kinetics. I will not go to details, right? We are still on revision on mechanics. So kinetics, what you just need to know in kinetics, it says the Newton's law of motion. I will start with the law, Newton's first law. I won't write them down. Make sure you know them, or you make sure you write them down. The first law of motion, Newton's first law, states that, because it might come out as theoretical question, states that every particle, are you getting it now, remain in its state of rest or uniform motion in a straight line except being acted upon by an external force. Now the first law, because this might also come out, the first law is the law that resulted to the principle of inertia. Are we getting it now? Or you can call it concept. Yeah, concept is more correct. The first law relates to the concept of inertia. And what is inertia? Listen very carefully, it might come out in your questions. Inertia is the tendency or reluctance of a body to remain in a state of rest or uniform motion in a straight line. Are we getting it now? So in inertia, I think inertia depended more of mass and center of gravity. Are we getting it now? All right. So inertia is a result from the first law of motion, which inertia means the tendency or the reluctance of a body to remain in a state of rest or uniform motion in a straight line. Okay, so the next one is the second law. What is the second law? The second law states that the time rate of change of momentum is directly proportional to the applied force or impressed force and takes place in the direction of that force. What does that mean? The time rate of change in momentum. What is change in momentum? Change in momentum is the change of a body mass and its speed together, right? So how a body can change. For example, you kick a football now. The way that football will move, the way it will change its speed, because when it's changing its speed, is together with its mass. Its mass and its speed, because momentum is mass times velocity. So how its mass and its velocity will change in correspondence to a force is directly proportional to the force. So the more the body will change its velocity is dependent on the force you applied. And the last part says, and it will take place in the direction of that force. Make sure you write it down. It means that the direction you apply to the particle is the direction that particle will follow. So once again, let me recall the second law. It says that the time rate of change of momentum is directly proportional to the applied force and take place in the direction of what? That force. So this is what brings this formula. F is equal to ma. F is equal to force. There's a derivation to this, but we are doing revision. M is equal to mass, and A is equal to what? Acceleration. Are you getting it now? Are you getting it? All right. So the unit for force is Newton. The unit for mass is kg. I already know that the unit for acceleration is meter per second square. Are we getting it now? All right. So let's take a simple question on this. Calculate the force. Calculate the force F. So we don't know force. We have source calculated. On a ball moving on a ball of 0.2 kg moving at a velocity of moving at an acceleration. That means m, when you hear 2 kg, that means m is equal to 2 kg, right? Moving at an acceleration of 10 meter per second square. So when we bring out our formula, so F will be equal to, what is m? 0.2. Then what is A? Our A will be 10, right? 0.2 times 10 will give us what? 2 Newton. Alright, so let's take another question. What acceleration will we produce? What acceleration will we produce? So that means acceleration is what? Acceleration here is what? Unknown. What acceleration will we produce? If a mass of 60 grams, right? If a mass of 60 grams is being hit by a force of 100, is being hit by a force of 120 Newton. So force equals 120 Newton. So first of all, this mass, you see that it's not in kg, so we'll try to make it kg by dividing it by what? 1000, sorry. So that will give us 0.06 kg. Okay, so we'll bring out our formula. Our formula is F is equal to ma, is it not? So our F here is given. Our F is 120 is equal to, our m is 0.06, right? Okay, 0.06, and our A is A is our A. So we make a solid formula by dividing through. So A will now be equal to 120 all over 0.06, right? 120 all over 0.06. So that means from here you can solve with a calculator, but we won't go into that now. So this is the trick I will use. If you understand it, it's very good. If you don't understand it, just press just do your own method. So that 6 going to here 1, 6 going to here we have 2, right? So that will be 2 and 0. So those 2 0, they are negative decimals, that is, they are going backwards. So when they go up, when you take them up according to law of indices, it will be now it will go forward. So that will be 2 0 plus those one that were backward, which was at the denominator. When they go up, it will now be what? They will now move to the right, so that will be 0 0. So our A will now be equal to 2000 meter per second square. Now if you don't understand, you can comment on the section below the particular place you don't understand. We'll try to help you out. Alright, so I think we are through with that. Now let's see what you can see in your Jamb question. Your Jamb can ask you a question on kinematics. A question like this: V is equal to U plus AC, right? And they will ask you to find, for example, they will give you U, right? They will give you T, but they will hide A. They will hide A. A will be equal to unknown, and they will ask you to find the velocity. They will ask you to find the velocity. In this kind of question, they will give you something like this. They will give you force. They will tell you a force acted on a ball. Okay, let us just take a question like that. Let's take a question like that. Right. Question: if a force of 50 Newton, a force F is equal to 50 Newton, acted on a ball of mass, are we getting it now? Of mass 25 kg. Are you getting it now? Acted on the ball of mass 25 kg at rest. So when you hear at rest, that means that U will be equal to 0, right? Now, if the ball accelerated in 2 seconds, if the ball accelerated in 2 seconds, so time 2 seconds, so that means that our time is equal to 2 seconds. We're getting it now. If the ball accelerated in 2 seconds, find the velocity of the ball. Find the final velocity of the ball. So what do? We can recall, we can use V is equal to U plus AT, right? But we don't have A here. We have U. U is 0. We have T. T is 2 seconds. We don't have A. What do? We remember that from here we have force, right? Equal to MA. So from here we can use A to be equal to what? Force over M, right? So force is 50, that is 50 over, that is 50 over, sorry, this 0 is, okay, that's 50 over 25. So 50 over 25 is equal to what? 2. So that means your A is equal to 2. So when you substitute here, that means V will be equal to 0 plus 2 times your T is 2, right? So everything will give you 4 meter per second. It's very, very easy. Alright, so I think we are done with this part. Oh god. So the next part we're going to is work, energy and power. So this part I won't do. I will just explain the main concept, because go to my previous video. I did work, energy and power, 3 parts. Part 1, part 2. No, it's 4 parts. Part 1, part 2, they were on the concept of work, energy and power. Then part 3 and 4 were problems, Jamb questions. So I will just run a quick revision on work, energy and power. So the first one is work. What is work? Work is done whenever a force move a body along a distance, right? So we can say that work is the same thing as force times distance, right? So if the work is inclined, or if the force is inclined, sorry, you can now say work is force times distance times the cosine of the inclined angle. So that's work is force times distance cos theta. Alright, now the unit for work is in joules. Joules, very important. It's not like this. It's joules, or J, capital letter J. Right. So energy. What is energy? The next thing, energy. Next thing, energy. But before we continue, remember we are on the topic work, right? Energy and power. So what is energy? Energy is the capability to do work. So we are through with work, we are on energy now. Energy is the capability to do work, or you can say energy is the capacity to do work, right? So how able you are to do work is called what? Energy. It's not only related to human being. Energy is the capacity to do work, right? So we have different type of energy. We have electrical energy. So when we're talking about electrical energy right now, we are talking about how current electricity is able to do work. The measure of that ability is called energy. I'm getting it now. All right. So the unit. So we can now say that energy, according to my equation, if you go back to my previous video, when I'm doing equation analysis, it is equal to work. Is it equivalent to work? Because the number of energy you have will determines what? The amount of work you can do. Are we getting it now? Alright, so it's still measured in joules anyway. So after that, we'll talk about types of energy. I will just focus on mechanical energy. We have solar, heat, those things. Can go back to my previous video. So let's talk about mechanical energy. What is mechanical energy? There are two types of mechanical energy. We have potential energy, which is the symbol is PE, P for potential and E for energy. And 2, we have kinetic energy, KE. Are you getting it now? Now, what is potential energy? Potential energy is the energy a body possesses due to potential energy is the energy a body possesses as a result of its height from the ground, right? That's why we call it potential. What is potential? Potential means something that is able to do, but it has not done it yet. So for example, now let's say a coconut is from the ground, right? It's on the tree from the ground. That coconut hasn't fallen down, but the energy on that coconut, due to the fact that when it falls, it can be able to do something. Maybe it can be able to hit your head and you will feel the pain. Are you getting it now? When it falls, the energy due to that coconut, when it falls from that height, is called potential energy. Now, so that means that potential energy is related to height from the ground, and the formula for potential energy is mgh, right? Where m is the mass, g is the gravitational acceleration, and h is the height. Now, kinetic energy with the energy of a body, are you getting it now, due to virtue of motion. The formula for calculating kinetic energy is 1 over 2 mv squared. So I did a video of all those things, so make sure you do well to watch them for detailed understanding. Alright, so if you want to get this video, it's very easy. Just go to my okay, I think I will arrange them. Just go to my playlist, go to physics, O-level physics, begin to scroll, you will see what I'm talking about. They are there. Okay, so after this now, the next one we'll talk about is power. Power. What is power? Power is defined as the time rate of doing work. Power is defined as the time rate of doing work. So we cannot say that power is equal to work over time, right? Also, power, there's another formula for power. Power is work over time, that is W over T. Also, power is force times velocity. Everything I did the derivation in my previous video. If you don't know how this force times velocity come about, let us do a quick review. We already know that work is equal to what? Force times distance, yes, right? Now, since now work over time, which is equal to power, is force times distance over time, right? And we know that velocity is equal to what? We have done this just now, s over t. So we can replace this by v. So we now have here f v. So that's how we have power to be equal to f v. The formula for calculating power has been dropped. The unit for power is in watts, right? The unit for power is in watts. So note that both work, energy, and power are all scalar quantities. They are not vectors. Alright, thank you very much. Also, force. Yeah, I think I did force before. I forgot to say this. Force is a vector quantity. Mass is a scalar quantity. I'll get it now. Alright. So I thank you very much for watching this. I think this will be our part 1. I would have loved to add elasticity, but the video will be too long. So in our next episode, we'll continue from here. We'll try to touch all the most important parts of physics relating to Jamb and WAEC and other examination. Make sure you share this to your friends, your loved ones, and also make sure you like this video, please. And if this is your first time of coming to this channel, please subscribe to this channel for more. God bless you.